So I've looked at two perimeter examples and we found out that we had 2 or even 3 different ways of coming up with a way to express the perimeter. Now we're going to start to see if we can put those things together and look for a pattern. So when we did our square, the 2 different ways people might have come up with an answer is they said there was 4 lots of A plus 2, or other people said, well, there were 4 A's and there was an extra 8 left over that we were adding together. With the hexagon example, some people said there were 6 lots of D plus 5, and other people said they added up all the A's. Oh, sorry, that should be a D. 6 lots of D's plus 30. So I want you to have a look at those numbers for a moment. If we'd had a pentagon that had 5 sides and each side was x plus 3, what do you think the other side of the equation might have looked like? I want you to write down a guess. It's okay if it's wrong. Well, perhaps some of you wrote down this. Perhaps some of you wrote down 5x plus 15. Now, if you did, maybe you're starting to see a pattern. If you didn't, maybe that's a third clue that might help you see the pattern better. So I want you to have a look in particular at this last number and the number inside the bracket. This last number and the number inside the bracket. This last number and the number inside the bracket. And what does it have to do with that number sitting out the front? I'm going to leave the pattern there because we might find we come to it a little bit later. So the distributive law really has 2 steps to it. It has one process which is called expanding and a second process which is called simplifying. Now, simplifying we've been collecting like terms. So we're really only looking at the first part of the process as a new thing. I guess what we need to have a look at is what do these brackets really mean in algebra, because we're not using numbers all the time and it can become a little bit confusing. So let's say we start with this. We've got 3 bracket A plus B. What does that statement actually mean? Well, the 3 outside the bracket is saying 3 times A plus B. It's saying I've got 3 groups of A plus B. So I could write them out if I wanted to. And this step here is what I would call expanding. I'm writing out the groups one at a time. I've got one group of A plus B, I've got another group of A plus B, I've got a third group of A plus B. And because I'm looking at groups and I want 3 groups, I have to add those 3 groups together. Okay. Now, if I've got A plus B plus A plus B plus A plus B, I'm going to use my skill of collecting like terms. I'm going to highlight all my A's the same colour. I'm going to highlight all my B's the same colour. And I can see then that I have 1 plus 1 plus 1, so I have 3 A's. And I have B plus B plus B, I have 3 B's. So if I collect those like terms, I now have 3A plus 3B. So this first step was the expanding. This second step of collecting like terms is the simplifying. So starting off with a bracket, an expression that includes a bracket, we can expand, then we can simplify, and that whole process is called using the distributive law or called distribution. Some people like to think of it like this. If I have 3 bracket A plus B, that 3 outside is multiplying. Okay, so this is a slightly quicker method. So this 3 is multiplying everything inside the bracket. So I have 3 times A, which is 3 times A. Then I have 3 times by B, 3 times B. And then I just use my algebra rules for writing. I drop out the multiply and I say it equals 3A plus 3B. So this is another way of using the distributive law. We expand it here in a different way and we simplify. And this is the way we're going to use most of the time because it is a little bit quicker and it doesn't take as much writing on the page. I'm going to show you that with another example. I'm going to work with 4 bracket G plus H. So that 4 on the outside is multiplying. So I'm going to start by multiplying it with the first thing I see. So 4 times G. Then I need to look at the next bit. Is 4 times by H. So 4 times H. And because I'm adding those things together, I need to have this addition sign. So 4 times H is 4. Then I use my algebra rules and I write it more simply. So I drop out the multiplier. 4 times G is just 4G, and 4 times H is just 4H. So I've started up here, I've expanded it, and then I've simplified using my algebra rules. My algebra can start looking a bit more complicated. You'll notice that inside the bracket I've actually got a coefficient to my pronumeral. I have 2 multiplying by A. But I can still use the distributive law the same way. Start with my outside and remember that it's multiplying everything on the inside. So 4 times by 2A added to 4 times by D. Now, 4 times 2A. Well, I can multiply numbers together easily enough. 4 times 2 is 8 times 8. And then I'm going to add. I'm going to simplify this using my algebra rules. 4 times D is 4D. This one looks a little different. On the outside of the bracket, I've actually got a pronumeral rather than a number, but I can still use the distributive law exactly the same way. So I think of it as this outside timesing by anything on the inside. So A times by 3x. Make sure those multiply signs are nice straight crosses and your x's are curly x's. Then I'm going to add A times by 2y. I want to try and simplify this. I've got A times 3x. One of our rules in algebra is we always put the number first, and when we're multiplying, we bring the letters together. I'm going to have 3. It's a nice idea to put the letters in alphabetical order. So AX, add a 2. Now I've got A times 2y, so bring the 2 to the front. A times y, make them smaller, put them in alphabetical order. AY. So there's some examples for you, which are slowly getting more difficult. Working partly on your own, partly with a partner, I would like you to work through all these questions in your book, and you can check them because they're just question 5 from exercise 8.6 in Maths Quest. Cheers.